Welcome to Camera Imaging Quality Testing with MTF, a complete guide, presented as part of the White Paper Series in Management Education by Skilled MBA. This session explores how the Modular Transfer Function, MTF, has become the gold standard for evaluating image quality across lenses and optical systems. Whether you're designing camera technology or assessing product consistency, MTF is the most objective, diagnostic, and actionable metric available. Let's begin our journey from the fundamentals to advanced applications of MTF. MTF, or Modulation Transfer Function, measures how well a lens reproduces contrast at various spatial frequencies. Its value lies in four core roles. Quantitative measurement provides numerical accuracy across varying frequencies. Visual performance indicator predicts detail fidelity. Diagnostic tool identifies flaws like aberration or distortion. Comparative analysis compares performance between lenses or sensors. MTF offers an unbiased, physics-based view of imaging quality. MTF analysis rests on three critical components: one-line pair measurement, LPMM, the base frequency metric; 2. Contrast ratios, the measure of distinguishable difference between light and dark; 3. Resolution benchmarks, the sharpness limit a lens can reliably resolve. Together, these metrics provide a complete picture of how well an optical system performs under real-world conditions. Precision testing demands a controlled environment. Optical Bench offers the highest accuracy for professional labs. Standardized camera rigs with stable mounting and lighting control for teams without bench setups. Calibration targets, such as Siemens stars or ISO 22233 charts, tuned to specific frequencies and analysis goals. Environmental control is just as important as optics in producing reliable results. Successful MTF testing relies on controlled lighting. Consistent illumination prevents false contrast readings. Optimal camera settings. Use native ISO, ideal apertures, and remote triggers to reduce noise and vibration. Multiple captures. Statistical validity improves confidence in results. These foundational practices ensure your data is both accurate and reproducible. Key software solutions include IMATest, industry standard with advanced reporting and batch processing; Opticos, high-precision platform trusted by manufacturers; MTF Mapper, open-source tool for customizable, cost-effective testing. Each tool serves different needs, from enterprise labs to academic use, but all share one goal: turning images into meaningful performance data. MTF curves reveal peak frequencies, where the lens performs best; drop-off points, where quality declines; center versus edge consistency; insight into uniformity improvement zones; targets for optical refinement. High-performing systems maintain strong contrast across frequencies. Deviation from the ideal curve signals room for improvement. Common issues include inconsistent lighting, leads to poor contrast measurements; misalignment, skews spatial accuracy; uncalibrated hardware, introduces systemic error; over-reliance on automation, misses subtle optical flaws. Mitigation requires a blend of technical precision and expert interpretation. To get the most out of MTF testing, invest in reference equipment, stable mounts, calibrated light sources. Document every variable. Record settings and conditions for reproducibility. Benchmark routinely. Compare against internal and external standards. Collaborate across functions. Involve R&D, QC, and product teams. Reliable testing supports continuous improvement and product confidence. MTF testing creates value across teams. R&D designs based on objective targets. Engineering translates specs into consistent builds. Quality control verifies performance post-production. Product management uses data for positioning and differentiation. Shared data fosters alignment, speed, and smarter decisions across the product lifecycle. MTF testing supports an iterative cycle. 1 test, initial prototype. 2, analyze gaps versus specs. 3, implement changes to optics or processes. 4, retest to verify improvement. This loop may repeat 4 to 8 times for premium lenses, gradually refining performance to commercial-ready quality. For expert users, tangential versus sagittal MTF, detect directional aberrations like astigmatism, chromatic MTF, measures sharpness across color channels, field curvature maps, visualize image sharpness from center to corner. These insights help optimize for real-world use, from microscopes to aerial cameras. MTF testing isn't limited to consumer lenses. Medical imaging ensures diagnostic accuracy. Autonomous vehicles enables visual reliability in complex environments. Satellite systems maximizes information capture from orbit. Machine vision supports quality control and robotics. In each case, the principles of MTF hold, even if the scale or stakes are much higher. This guide delivers value across user types, R&D teams, for performance-based design decisions, quality engineers, for standardizing product control educators and students, for teaching applied optics photography enthusiasts. For smarter gear choices, MTF knowledge empowers every level of the imaging ecosystem. Let's summarize. 1. MTF is essential. It gives objective, scalable insights into image quality. 2. Methodology matters. Consistency, control, and calibration are key. 3. Testing enables growth. It drives continuous optical improvement. 4. MTF serves everyone, from engineering to education to marketing. By applying this knowledge, you can lead your team toward higher performing, better documented optical systems at scale. Thank you for exploring camera imaging quality testing with MTF, a complete guide, presented by the White Paper Series in Management Education by Skilled MBA. Whether you're developing next-gen cameras, building smarter testing systems, or simply seeking sharper insight into optics, MTF is your most powerful tool. We hope this guide has provided both foundational knowledge and practical strategies for applying MTF with precision, confidence, and purpose. Let's continue advancing imaging, 1 pixel at a time.